You walk into the jungle. Your heart rate spikes. Your eyes scan the grass for something long and coiled. This is instinct. This is ancient. But the real answer to what actually kills the most humans on Earth every year is far stranger. And it isn't hiding in the grass at all. It's flying past your ear right now. Not a lion, not a shark, not a snake, even though snakes come close. The deadliest animal on the planet, year after year, is the mosquito. A creature so small you can crush it between two fingers. Kills more people annually than every shark, wolf, and crocodile combined. Hundreds of thousands of lives gone from something with a wingspan smaller than your thumbnail. So why doesn't it feel that way? Why does your body flood with adrenaline at the sight of a snake, but barely register the whine of a mosquito circling your bed at night? The answer isn't about danger. It's about timing. Your brain isn't calculating real risk. It's replaying a very old script. Your ancestors did not evolve in a world of malaria statistics and disease vectors. They evolved in a world of teeth and claws. For millions of years, the threats that mattered most were the ones that could kill you in seconds. A predator in the tall grass, a venomous bite, a fall from a cliff. These were fast, visible, immediate. Natural selection built your fear response around exactly these kinds of threats, and it built it fast because the humans who hesitated didn't survive to pass on their genes. This is what psychologist Arne Öhman at Sweden's Karolinska Institute spent decades studying. In research published with Susan Minica in 2001, Öhman showed that human brains detect images of snakes and spiders faster than almost any other visual stimulus. Faster than flowers. Faster than mushrooms. Faster even than guns, which are statistically far more dangerous to a modern human than a snake will ever be. Öhman called this a fear module, a piece of ancient software still running, still scanning for threats, that mostly disappeared from your daily life a long time ago. Here's the strange part. That software wasn't built to protect you from what actually kills you. It was built to protect you from what killed your ancestors. And those are two very different lists. Think about what modern death actually looks like. Heart disease, car accidents, diabetes, mosquito-borne illness. None of these are fast. None of these have teeth. None of these trigger the ancient alarm bells wired into your amygdala, the almond-shaped structure deep in your brain responsible for processing fear. Your amygdala was built for the visible and the immediate. It was not built for a slow drip of risk delivered across decades or a tiny insect landing silently on your arm while you sleep. This mismatch has a name. Evolutionary psychologist Randolph Nesse, who helped found the field of evolutionary medicine at the University of Michigan, calls it a mismatch between ancestral environments and modern ones. Your body and brain, Nesse argues, are still calibrated for a world that no longer exists. You carry Stone Age instincts into a world of steering wheels, processed sugar, and insect-borne pathogens invisible to the naked eye. The hardware never got the update. So what happens to fear when the amygdala doesn't fire? There's a case that shows you exactly what a human without functioning fear looks like. Researchers at the University of Iowa, led by neuroscientist Justin Feinstein, studied a woman known in the scientific literature only as SM. Rare damage had destroyed both sides of her amygdala. Feinstein and his team tried everything to frighten her. Haunted houses, snakes, spiders, horror films. Nothing worked. She reported curiosity, not fear, even when a knife was held near her throat during one documented incident. SM was not reckless. She simply lacked the ancient alarm system the rest of us carry. And here's what her case reveals. Fear isn't really about logic. It's about inheritance. You didn't choose to be afraid of the dark. You didn't choose to flinch at a spider before your conscious mind even registered what you were looking at. That decision was made for you generations ago by ancestors who never faced a mosquito problem anywhere near as deadly as the diseases it carries today. Malaria alone has shaped human evolution more than almost any other force on the planet. It's part of why certain genetic traits, like sickle cell trait, persisted in populations exposed to it for thousands of years, because carrying one copy of the gene offered partial protection against a disease invisible to the naked eye but deadly all the same. Your ancestors couldn't see malaria coming. They couldn't build a fear response around a threat they couldn't observe with their own eyes. Fear needs a face, a shape, a sudden movement in the grass. Malaria offered none of that. It simply arrived, silently, on wings too small to notice. This is why you can walk past a swamp without a second thought, but freeze at the sight of a spider in the corner of your bathroom. It's not that your brain is broken. It's that your brain is old. And this pattern doesn't stop at animals. Think about how you respond to other modern risks. A plane crash dominates headlines for a week, even though flying remains extraordinarily statistically safe. A car crash barely registers, even though driving kills far more people every single year. Why? Because a plane crash is vivid, sudden, and visible in your imagination, exactly the kind of threat your ancient fear module was built to detect. A car crash is mundane, familiar, slow building in its statistical danger, even though any single trip carries real risk. Your brain isn't measuring probability. It's measuring how much a threat resembles the dangers your ancestors actually faced. This is also why public health campaigns about mosquitoes struggle so hard to change behavior, even in regions where malaria remains a leading cause of death. You can hand someone a bed net. You can explain the statistics. But convincing a human brain to fear something small, quiet, and slow-acting fights against millions of years of wiring built for teeth and claws instead. So the next time you feel your pulse quicken at a spider crawling across the floor, notice what's actually happening. You are not responding to today's world. You are responding to a world that mostly no longer exists. A world of open plains and immediate predators, replayed through a nervous system that never got the memo that the danger moved on. The lion in the grass retired a long time ago. Something smaller took its place, and it never even needed to make a sound. Tonight, when you walk outside and hear that same jungle instinct kick in, scanning the ground for something long and coiled, remember what's actually flying past your ear. The real answer to what's most dangerous was never in the grass at all.